Yeah, let's now talk about converting the tokens into token IDs. So previously we talked about breaking down the text into individual tokens here. And now in this video, we are going to talk about converting the tokens here into token IDs, which are so-called token IDs, and they are essentially unique integers. So how do we do that? The first step, let's maybe go to section 2.3 here. The first step would be building a so-called vocabulary. So the vocabulary is the unique mapping between each word that can occur and a unique integer. So for example, for simplicity, if we have a very small data set here, the quick brown fox jumps over the lazy dog. The first step would be breaking down the text into tokens, which we have done before. And now we are going to sort them alphabetically, making sure we don't have duplicates in there. And then we are going to assign a unique mapping here to integers. So how do we do that in Python? So we already have the preprocessed from the previous section. So preprocessed is all the unique tokens in the data set. And so what we can do now is we can get rid of the duplicates first. So we can do set preprocessed, which will get rid of the duplicates. And then let's also sort them with a sorted function in Python. And we can assign all words a variable to hold them. So let's just make sure it worked. So we can see these are all the unique words. It's a lot of words. We can actually also look at how many we have, how long this list is. So that's about 1,130 words. So it's 4 times smaller than preprocessed. So we had a bunch of duplicates in there. Let's actually save that for later. We call that the vocabulary size. So how many unique words we have. And so the vocabulary size is shown below 1,130. So next, let's actually build the vocabulary. This is actually quite simple in this illustration for educational purposes. What we can do is we can, for each token, assign an integer, a unique integer. For each integer token, enumerate all words. So what it will do is it will iterate over all the unique words and then assign in ascending order these integer labels. So we can actually take a look at this. So you can see it's essentially mapping each word to an integer here. And this is essentially what we are doing here. So now we have the vocabulary. So maybe going to the next figure. So the next step would be, now that we have this vocabulary, we use this vocabulary to actually tokenize training data into token IDs. You can see the vocabulary is in a sorted order. So we have them alphabetically sorted with this mapping. And now for any new text, for example, the training text, but also later on when we want to use the LLM, we are going to use this vocabulary to convert any text into token IDs here. So basically using the vocabulary mapping, if we have the word the, we would find the word the in the vocabulary and find the corresponding integer, for example. So the here, it's not shown because it's too long, would correspond to integer 7. And then the second word, brown, would correspond to integer 0. And then dog would correspond to integer 1 and so forth. And so this way, we are going to encode the given text into these token IDs. So let's do this in Python. So I will actually copy and paste here, because otherwise it will take too long if I just type it, and I will make errors, because typing in front of a camera is quite different than coding in silence. But so here what I'm going to show you is a simple tokenizer class, and that's a Python class. And that does the following things. So init is usually executed when you are instantiating a new object, which we will be doing later. Let me just maybe first explain, and then we will create a new object here. But so init is the constructor. It takes a vocabulary and it defines, or it will just save the vocabulary as the string to integer mapping. So string to integer means that we are mapping from strings to integer representations. And then we also have the same thing inverted. So we are here, instead of having is, we have si, which inverts string and integer. So what it will do is it will create this mapping from integer to string now. So we have integer and string, inverting this essentially. Yeah, so here we have now two vocabularies, the regular vocabulary and the inverted vocabulary. And then we have an encode method that takes any text and uses the regular expression from section 2.2 and breaks down the text into tokens. So this is what we have seen earlier. This is quite the long vocabulary if I scroll up. So let me actually maybe comment this out. So earlier in the previous video, we have broken down text into tokens. So we used this regular expression. So here we are just going to reuse that regular expression from earlier and then strip out the white spaces. And then here, this is the interesting part. This is where we are creating the token IDs. So we are going to use the vocabulary from here. And for each token or string in preprocessed, we are going to convert it. So just to show you what that means. So if I just take, let's say, Jack here, and I pass it to my vocab. So if I have something like this, so this should give me an ID, right? So this is essentially the token ID, and I can also maybe just show you to create a reverse mapping here. So if we want to go back to string and type the 57, this should give us the original word back. So this is basically what's happening here. We have a vocabulary, inverse vocabulary. Here we are just going from string to integer. So string to integer means this one here. We are going from a string to this token ID. And we do that for each token ID in the data set here. And the data set is the tokenized version of the text. And this is really it. And then we have a decode method, and the decode method goes backwards. So here we are going to recreate the text by mapping back from integers to string, which is what I've just shown you. So integers to string means that we go here from the integer back to the string. And I think, this might be relatively, complicated, maybe not, but it's a lot of information. So in this case, let's actually use it, and I think it becomes more clear when we actually use it. So let's do simple. Unfortunately, I don't have autocomplete here, so let me just copy it from here. Let's actually just instantiate a new object using the vocabulary. Like this. Oops, not defined. I need to execute this cell first. This always happens when I talk and code at the same time. I forget things. Then let's just use some text here. Instead of me typing it, I'm just copy and pasting it. And so the first step is converting text into these IDs. So let's do tokenizer.encode and then text. So this is essentially calling this encode method. And then we will hopefully see that those are converted into token IDs. So we can see now this would be the token ID representation for this particular text. And we could also go backwards. So if we have these token IDs, we can do tokenizer.decode and IDs, and this would correspond to this code. This will be converting this back into text essentially. And what's nice is you can do also the round trip, which means what we can do is, let's do it like this, decode and then put this encoding inside here. And this should give us the original text or something that is close to the original text. You can see there are a few slight differences. For example, here we have this additional white space, for example. But overall, this works quite well. We have a way of converting text back into from token IDs back into text. So this would be a very simple tokenizer. That's not the real tokenizer that is used by GPT models. That's why I'm calling it simple tokenizer. But I think this illustrates the concept of tokenization quite nicely, how we go from text into integer presentations. And now in the next video, we will talk a bit about special coding, special tokens, and how we handle those.
Get this book at Manning.com.